Let's discuss exercise 3.1, page 74 from your textbook to make you understand more about linear function. Let's use this function. Y equals x plus 5. Okay, let's use the conventional method by using the table of pairs. So when I just using 5 as my x, so my y will become 10. So and then it's 0, 5, negative 5, and 0. So by 3 pairs, actually 2 pairs is enough. 2 pairs is enough for you to draw a straight line, since we have known that linear function will form a straight line. But let's just try to plot these 3. Okay, first 5, 10, this one, and then 0, 5, this one, and then negative 5, 0, this one. And then let's connect it with the straight line, and this is it, the brown one. And let me give a label to it. So this is the first line, y equals x plus 5. Now let's go to the second function that is referred on the textbook. For this one, it's y equals 3x plus 5. See, we only add a different coefficient of the x. Before it's y equals x plus 5, now y equals 3x plus 5. So by using the conventional method, so when I use 0 as my x, let me just get clear. If it's not specified, it means that we use the domain all real numbers for your x. So the next pair, I will use negative 5, and the y is negative 10. So 0, 5, we have already had the dot here. And then the second pair will be this one, negative 5, negative 10. And when we connect that with the line, this green one, this is the solution of your equation, of your function, y equals 3x plus 5. So remember that this line shows all ordered pairs that satisfy this equation. So now let's go to the third one. If I want to use y equals 2x plus 5, when I use the conventional method, let's just skip the table of pairs, let's just graph it. So this is the line. This is the solutions of all the ordered pairs that satisfy this. Let me just go to the fourth, which is this one is negative 2x plus 5. Okay, so see, there is a similarity from these 4 equations actually. Look at this, 3x plus 5, y equals x plus 5, y equals negative 2x plus 5, y equals 2x plus 5. Okay, even if I'm using one more, which is y equals 0x plus 5, the graph will be like this. And I will explain to you further about why it becomes a horizontal line like this. But in the end, you get the hint. So they are all intersects the y-axis at 0, 5. Okay, so this 5 refer to all of this constant on the equation. So 2x plus 5, 0x plus 5, this 5 indicates the y-intercept, the intersections with the y-axis, since all consistently intersects the y-axis at 0, 5. Let me show you another pattern that really interesting about linear function. So if we go to this first line, which the equation is y equals 2x plus 5, and then I will take another different equation, this one, y equals 2x minus 5. So there is a difference there. The line will be like this. So it will, since the intersection will be negative 5, which I will explain later. It will be like this using the conventional method. Okay, and then if I'm adding another one, for example, y equals 2x plus 0, we will have this as your graph. So what is the similarities of these equations that will make a pattern to this line? So actually the similarities is the coefficient of the x. This one, and this one all have 2 as the coefficient of the x. 2, 2, and 2. but they have different constant at the end, which refer to the previous examples. It indicates the y-intersection, and it's constantly showing. So this one, the y-intersection, the y-intercept is at 5. This one, the y-intercept is at 0. This one, the y-intercept is -5. But let's go to this pattern. So actually, all of this graph, if I'm just slide it into this and slide it into this, it has the same slope. They all have the same slope. Okay, let me just, when I drag this, it's exactly the same slope. So that means this coefficient of x show you what is the slope of your graph. So in the end, let's answer the questions that follows from the same page of your textbook. So why are first degree functions called linear functions? So the answer will be the first degree functions are called linear because the solutions graph shapes a straight line. So yeah, after you do many trial of with the conventional method, you will just can give a conclusion that linear first degree functions will always shape a straight line. What is the effect on the graph of changing the coefficient of x? Okay, so let's just refer to this. Okay, we have used many examples before, and I'm referring to this m. Okay, the coefficient of x. We use m for that, for slope. Later I will discuss more about this. So when we change the coefficient of this, the effect is it changed the tilt or slope or gradient of the graph. Okay, and then the third one, what is the effect on the graph of changing the constant term? So if I'm changing for this part is the constant, the second term on the right member, the b one. We indicate it with b. So the effect is it changes where the line crosses the y-axis. The intersection to the y-axis will be determined by the value of b. And then number 4, what are the spatial names given to the constant m and b? So yeah, so far we have been introduced by slope for m, and b is y-intercept. Okay, and if m equals 0, the graph is a horizontal straight line, yet the function is not called linear. Why not? Okay, since the equation of y equals b is a constant function rather than a linear function. Yes, because we have no degree on the right member. Usually if we have bx, for example, like this, then we have a linear function. But since it's just a constant, so b is not a variable, this one. Okay, let me just get it clear. This m and b is just referring to a constant that we don't know because we are not talking to a specific line, talking to a specific function. So I hope by answering all of these questions, this will be a good introduction for us to go further, go deeper about the linear function. Let's just go to the next section so I can describe more further about the characteristics of linear functions.
Linear functions, we know that it will shape a straight line. There are 3 characteristics that we want to discuss now. The first one is the x-intercept, the second one is y-intercept, and the third one is slope. Okay, the first characteristic is x-intercept. Now I will give you these 2 graphs. Okay, these 2 graphs. I have already given you the function. So speaking about x-intercept, x-intercept means the intersections of your graph to the x-axis. So when your graph, like this green one, intersects with the x-axis, this is the x-intersection. For the red one, although it's not visible on your graph, but you know eventually this graph will just cross or intersects with the x-intercept. So the x-intercept will be the intersection again with the x-axis. And for linear function, for a line, they always have one x-intercept. never more, never none. As long as the specified domain is all reals, all lines has one x-intercept. How about y-intercept? Y-intercept is the same. The intersections of your graph with the y-axis. So y-intercepts for the red line is this. This is the y-intercept. For the green one, the y-intercept is this one. Okay? So let me just go here to the definition. So the x-intercept will be the intersection with the x. But if I use the ordered pair, the x-intercept will consist of the value of the x-intercept and the 0 for y. Okay, so let's go back to the graph. Let's see the green one. If you have the intersection is this one. So you can figure out that the coordinates or the ordered pair of this one is some number. Yeah, it must be a fraction. It can be 0.5, but you cannot assume. Let's calculate later. And then comma 0. Since we know that the value of your y is 0. So our x-intercept always have the value of y equals 0. So if we go back to the definitions, I can say that this is the value of x when y equals 0 for your ordered pairs. So y-intercept means your ordered pair of your function. I will change the language here for your function when x equals 0. So your intercept must be 0, comma, a number. So if I go to this example, the y-intercept, the intersections of the red line is around here. And you know that the ordered pairs or the coordinate of this will be 0, comma, something. Right? But we don't know. But this one, the green one, well, it's obvious. So the y-intercept will be at this point. So the coordinate or the ordered pairs will be 0, comma, negative 1. Okay, so the green line or this equation has y-intercept 0, comma, negative 1. So again, for the y-intercept, for all the lines, for all linear functions with the specified domain, all reals, we'll have only one y-intercept. You can see the red line, only one, the green one, only one. And you can be sure, as long as it is a straight line, it only has one y-intercept and one x-intercept. Now let's go to the third one, slope. Okay, slope, or usually we use another terminology, gradient. Okay, for this one we use the representative m for slope. So we use m. Okay, so m, the common formula for slope, usually it's rise over run. Another common general formula for this is delta y over delta x. Or if I want to describe this, it is y2 minus y1 over x2 minus x1. Okay, you can imagine that when we're speaking about slope, let's just imagine that you have a car riding on that line, goes to the right. So for this one, so the car is here, it's going there. Okay? For the red line, the car is rising. So it's rising. So the m always positive. The gradient value must be positive. For the green one, since it is decreasing, it's just going down, it will be negative, the gradient or the slope. So how can we find the value of the slope? So each line will have a value of the slope. So for the red one, you have to pick at least two ordered pairs to find the slope. For example, we have 1, 2, 3. Okay, 3 known pairs. If I can extend, this is the fourth. So just pick 2. For example, I will pick this one and this one. Okay, let me just erase the card here. How to find the slope by using rise over run? From here to here, it rise one time, and then run 1, 2, 3, 3 times. Positive. Rise if it is going up, positive. Run if it is going right, positive. So if I use the formula here, the red one, the slope is 1, rise 1 time, over run 3 times, 3. So the slope of the red line is 1 over 3. So let's just use different perspective here. Okay? So I don't want to use the 2 pairs of...
A few minutes later.
So I want to use this one and this one as the reference. Okay? So from here to here, let's count. If you are going from here into here, you are making 1, 2 rises. Let me just 2 rises up, positive, and then how many run? 1, 2, 3, 4, 5, 6 into this 6 run, positive, going right, positive. So in the end, you will have a consistent value of the slope. So do not be afraid, Mr. What is the ordered pairs that I need to pick? As long as it comes from the line and you pick only 2 ordered pairs, you can find the value of your slope. Okay? Let me just give you another example. If you want to do the extreme way, if I want to go from here to here, so it's still on the same line, so you don't we are not violating the regulation. So let's count. If I'm going to here, from here to here, it means I'm going down 1 time. So the rise will be negative because I'm going down. So I will put it into the formula, -1. And how about the run? From here to here, I'm going left. 1, 2, 3. Because I'm going left, it is negative, -3. So, -1 divided by -3, which is also the same with 1/3. So, again, you can use different approach. As long as you know the concept of the slope, the value will be consistently 1/3 for the red line. Let's use the second formula, and I will apply it to the green line. So, delta y over delta x. So, let's go to this green one. Okay. Now, I will pick 2 ordered pairs that you know from here. Let me pick this one. Okay, I know that this one is -2, 3. And then the second one, I will use this one. Okay, 0, -1. So, I will have 2 pairs, which is, let me use the green, -2, 3 and 0, -1. Let's just say this one is the first, this one is the second. Okay? When I use the formula to find the slope, so the slope will be equal to y2 minus y1 over x2 minus x1. So the second y is -1. The first y is 3 over x2. The second x, this is 2, this is x, so it's 0, minus x1, -2. So in the end, it will be -4 over 2. So the slope is -2. Or I can give you another example. If I want to do the opposite, so how if this is the first one, and this is the second one, it will be consistently the same. So let me just write here. So it is y2 minus y1. Again, I will just do this. Okay, so the y2, this is the second. So y3 minus y1 is -1 over, so it is negative 2 minus 0. Okay, so it is 3 plus 1 over negative 2. 4 over negative 2 equals negative 2. So in the end, you know that the gradient or the slope of the green one is negative 2.